Okay, it says consider the differential equation. Therefore, I have an equation which can be used to find the rate at which some amount is changing. So I have this. I have an equation for finding the rate, dy over dx. That means the amount would be some formula for y, or whatever. Or we could call the formula over here f of x. Same idea. Just whatever. It says that y, or f of x, just like we wrote here, those are representing the solution to the differential equation. It's a really big idea. If you had an equation that was very simple, you would say the solution to this equation is the value of x, which makes the equation true. So, over here, the solution to this equation is an equation for y that if I plug into this equation, it'll make this equation true. So you have to memorize that the solution to a differential equation is another equation. Another equation that will make the differential equation a true statement. But that doesn't ask me to do anything, it's just stating what they're giving me. So they're giving me the equation for finding the rate, and they're asking, and then they're stating that there is a solution. That would be the equation for finding the amount. They're not asking me to find that yet. Part A says, a portion of the slope field for the differential equation is given below. Sketch the solution curve. So they want us to sketch this formula, or this formula. The reason we can do it is a slope field is a picture of what the graph of the amount will look like. Because when you make a slope field, you use the formula for calculating the slope to find slopes. So our solution curve is supposed to go through point 0, 1. This says 3, so here's 0, 1. Right there, you can see the slope field looks like that. That means that's what f would look like as it goes through that point. So if f goes through this point, it looks like this little blue line. And now what you've got to do is you've got to connect the field. Well, it doesn't make sense to go like this, because that's not typically how a function f is going to look. So I'm not going to do that. Instead, I've got to follow the field. So my curve's going to kind of go smoothly like so, until I find another right there, merge with that slope. So that's getting me to turn a bit, kind of like that. And here's where I don't know how picky they are on grading, to be honest. You just kind of gently follow the field. Just little by little, carefully following the flow of the field. Do the same thing this way. Don't spend a lot of time. It's only worth 1 point. That's all I've ever seen these worth. But it's worth giving it a try to see if you can get the point. So that's my attempt. Whether that would earn the point or not, I'm not positive, but I think I get the point. Here's what their solution looked like. They went quite a bit deeper than I did, but I do think they'd be a bit forgiving on that. So 1 point, if you have a curve, it does have to go right through here. They specify that. How much you go up, how much you go down is a bit subjective. So just do your best to follow the field. 1 point for that.